Okay, last one, aluminum hydroxide and carbonic acid. And conveniently, Mr. Huber gave you the formula for carbonic acid. We haven't talked about acid names and formulas yet. All right, so aluminium, if you are from the other side of the pond. Right, Al3 plus and hydroxide. This is one of those two polyatomic ions that ends in IDE, but we just got to learn to recognize those. It's not hydrogen. It's not just oxygen. It is OH minus, right? So my formula for aluminum hydroxide, because my charges are not balanced, that means I need 3 hydroxides, 1 aluminum. So Al. Now hydroxide is a polyatomic ion, so whenever I want to add a subscript, I put the entire thing in parentheses and then get the subscript. All right, and it's going to be combined with carbonic acid, which looks like H2CO3. All right, this looks like an ABCD reaction, which would make this double replacement. So I've identified my reaction type. Now I need to predict what my products are going to be. So again, right, if we have an AB plus CD, all we're doing is the A and C are swapping partners. Okay, which means the aluminum is going to combine with the carbonate here. That's CO3, that's a carbonate. Okay, now we can write it like this: H plus, and let's just do this, H plus and CO3 2 minus, right? So you got to kind of start recognizing those polyatomic ions when you see them. You know the carbonate, that's CO3, is a 2 minus. So aluminum carbonate, to combine those, I'm going to review this one more time, just in case you don't have it down, right? Aluminum and carbonate will combine as AD, and then my hydrogen and hydroxide will combine, actually just to make water, which can be written as HOH. So let's do my A and B first. Fix this just to make it less messy. All right, so my A and C are going to swap places, right? So let's put hydrogen with hydroxide first. Okay, so it's a +1, -1, so no additional subscripts needed. So we can just write it like this, which, by the way, is just H2O. But let's just leave it as HOH because it's easier to balance that way, and we'll talk about why here in a minute. Okay, and then we're going to add to that my AD, so my A is going to swap here. So I have aluminum, which is a 3+, carbonate, which is a 2-. Those are not equal and opposite charges, so I'm going to have to do my crisscross method. I'm going to have to give the 2 to aluminum. Al2. The 3 goes to the carbonate. Now, that carbonate looks like this, CO3. That 3 is already a part of the carbonate, so that does not account for the +3 charge. I need to add a subscript. Right, that 3 there makes this carbonate, and that 3 there makes carbonate a -2. All right, which is why I put the 2 there. The +3 from the aluminum, in order to balance the total charge, right, I need to put a 3 there, like that. Again, that is a review from last unit, so I'm doing you a favor by breaking that down a little bit. So I've now predicted the products and written the correct formula for products. Now, writing the correct formula sometimes puts us out of balance, but we don't balance with the formula, we balance with coefficients. Okay, deep breath. So on my left side, I've got 1 aluminum, the way it's written. I've got hydroxides, 3 of them. I've got hydrogen, 2 of them, and carbonate one of them. On my right hand side, I've got aluminums, 2. Hydroxides, 1. Hydrogens, 1. Carbonates, 3. All right, so let's just start at the top of the list. I've got 2 aluminums there, 1 there, so that means I need to put a 2 there. That makes that 2. But it also makes my hydroxides 2 times 3, 6. All right, now if I want to balance out my hydroxides, I'm going to have to put a 6 here. Make that 6. That underline, I think this is going to confuse people. Okay, that's there. Now by putting 6 hydroxides there, that also made my hydrogens 6. So in order to turn my hydrogens into 6 over here, I'm going to have to put a 3 there. 3 times 2 is 6. Which also gave me 3 carbonates, 3 carbonates,